Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Thank you for joining us. I'm your host, Ben Crossman, and I hope all of you are having a great day. Thank you for joining us here on the program because we have a great show lined up for you today where we are going to be talking to a company called, well, KnowThings. And you can find a link to them in the show notes over at computeramerica.com. And hey, just like everything else, you can find a lot more. So with that being said, we are going to go ahead and just get started. So actually, a couple of things before we do. ComputerAmerica.com. We have the social media contest brought to you, of course, by Logitech. And be sure to check out the live video stream brought to you by OWC. So both of those things and more at our website, as well as articles, reviews, things like that. And all right, so let's just get started, and here to tell us all about the company KnowThings and what they do, how they do it, is probably the best person to explain this to us, and that is the CEO and founder, and we're gonna call him AK. But hey, I have to give this a try, Mr. Anand Kameswaran. There we go. So Anand, or AK, welcome onto Computer America. Oh, just one moment, and all right, there we go. I'm sorry. Welcome onto Computer America. Yeah,
glad to be here.
Yeah, happy to have you. So I think we should, kind of get a little bit of a background. What is your background? And tell us about the company. What is your background, and why did you decide to go out on your own? Why did you found KnowThings?
So actually, I started programming about the age of 9, and pretty much since then, I've automated anything that I could. Actually started more from a music background, automated like a digital audio workstation, and really just had an obsession kind of with, how do we automate things? How do we make processes and everything more efficient? Even when I was 10, so a real popular kid. But after I got out of college, joined up with a startup and then got into CA Technologies, and spent the bulk of my career there working on enterprise software. But meanwhile, my nights and weekends were still spent on automating things, and really got into sort of gardening and sort of automating agriculture on a small scale. At the same time, I was working with CA. Now, about 3 or 4 years ago, CA had a partnership with the University of Swinburne for strategic research. And we had pioneered using machine learning to basically understand machine protocols. We were using that to tackle challenges with aging mainframe systems where nobody knew what the data that was going back and forth anymore. The folks had either retired, everybody in the know. Mm-hmm. So we developed this algorithm that can basically learn any message protocol.
That is, and that's one thing where I think automation hasn't, because we hear about automation and how it can do, menial tasks. It can do, relatively more and more complex as things go on. But I guess, the back end of it, designing automation and, exactly what you're talking about. We've heard a lot of the Internet of Things. Do you think that what you're doing extends beyond just simply, programming light bulbs? It's going to be, kind of almost a self-sufficient thing where you don't have to be a programmer. It's going to get to a point where, everything is just going to kind of speak its own language and kind of set itself up.
Yeah, no, that's a great question. Like actually today, sorry for the hotel room background, but I'm out at a conference in Atlanta called Aglanta, where they are looking at the intersection of smart cities and smart agriculture. So, at this point, it's not really just about the pure automation, right? I mean, we've been doing that for 20, 30, 40, 50 years in some form or another. The fact that things now talk to each other and that we can gather that data is really that key aspect that is, I think, frankly, going to be transformational for society. Like if we look at agriculture, where we need to feed an ever increasing population of people, there's only so much you can do when it comes to the biology with fertilizer or other things, and not to mention, we have all the challenges of runoff, the inputs and outputs. So, a lot of the great thing about the Internet of Things is now that we can start to monitor and collect all the data on how plants are growing. When is the right time to water? When is the exact right time to add a fertilizer? Check, the overall light levels for how things are growing, and this is going to drive the next 20 to 30% increase in yields. From an agriculture standpoint, and become a lot more sustainable. There was talk about the shortage of phosphorus that is sort of impending for agriculture worldwide,
Mhm.
and I really think it's this level of intelligence and the ability to control those types of systems that will let us do more with less. That magical thing we're all searching for. Use a lot less to create more in the end.
Right. And like this is super interesting, and I think it's going to happen very surreptitiously in the background because this is not something that uh, automation is automation, just as you were saying, and it's it happens independent of what we do, and it just makes things easier. Now, of course, I have to, or I feel like I should, kind of bring up that there's been a lot of news, just to tie this into current events, about the amount of data collected on individuals. And, for advertising purposes and things like that, things get a little gray. But I can imagine someone in your field, you have the amount of data and you can glean a lot of different trends. You can glean, how to make, you're talking about how cities were becoming smart cities, roadways, and how they become, when they become congested, when they don't. You can talk about electricity. You can talk about, a lot of different things. I guess my question is there such a thing as too much data, or because data drives what you do, but I guess people can be a little afraid of, are they using it properly, I guess.
So, one, I would have to say there definitely can be too much data. There's definitely a trend, I think, right now for people to just go ahead and collect data, even when they don't know exactly what they're going to do with it later. And I'm not sure that's the healthiest trend. I mean, I think the good thing is as we see the impacts of it, that will probably be drawn back and pulled back a little bit. But that also leads to some of the value that we have with KnowThings. So what we do with KnowThings is we create simulations of that type of data at scale with what we call a virtual device. Now, the reason this is relevant here is while we start with a live and real data set to train the machine, when we do the playback, when we do the development and all the engineering work, we're now using synthetic data. So it's not actually the real data anymore. And so when you are a company trying to build some of these large solutions, one of your risks is losing data out of your test environments, right? So if you use production data, that can leak out, particularly when we talk about medical devices and things
Mm-hmm.
like that. You have HIPAA requirements. So one of the advantages when you use KnowThings to help build your solution is since we basically profile your original data and then use machine learning to recreate ultimately, if you want infinite variations on it, we have stripped out the personally identifiable information and removed the real data. So you can still test your system. You can build those control and automation systems, but while you're doing that, you're not exposing anybody or anything's real data if you don't want to. So it's one of the things I pay quite a bit of attention to, and why I think simulation is one of the better ways to go about building things. Use simulated data. Don't use real data when you're trying to build and test. All you're doing is exposing greater risk and making all of these things, just makes it easier for bad actors to hack and steal your data. But hey, if it's all been faked because we have a smart algorithm that can recreate it, then no harm, no foul. They've stolen data that doesn't have true value from that perspective.
That is very interesting. I've never heard of actually recreating the data. It makes perfect sense. I mean, when you think about it in retrospect, but time and time again, we've seen real identifiable information stolen by a lot of people. So that's that's a very awesome thing that KnowThings does. Let's talk about why you have decided to do this whole self-learning thing, because there are a lot of programmers and a lot of PhD level people out there who are willing to go through and try to develop systems for people with I don't know if it's more personalized, but I guess my point is like there's a lot of people working in this field. Why did you decide to go with self-learning, Internet of Things, and this virtualizer instead of gathering a team and getting researchers and trying to build out a human solution to developing solutions for people?
Oh, so it's not really an either or. I mean, the result of what we do has been with close collaboration with some really smart folks over at the University of Swinburne, developing that machine learning algorithm. And we continue to work with them on sort of the next generation of how we can enhance and increase the capabilities. Sort of what it comes down to at a certain point is for IoT, we talk about large amount of data, and the other thing is it's not just in one problem space, right? It's everything from monitoring the shelves in retail stores to building medical devices to integrating those with hospital systems so that the right care happens at the right time to a lot of the moves now with smart agriculture, which is kind of personally close to my heart. So when we're looking at the problem a few years ago, what it really comes down to is there's not enough smart people in the world for each of these problem spaces. The kind of traditional way when you need this kind of high fidelity data is you get a data scientist or people who are experts in that underlying technology, and you build a simulation, a mathematical simulation, say in something like MATLAB or these other type of tools. And it takes weeks, maybe months, maybe even a year to create an accurate model. So, we were first just trying to decode computer messages, but as we continued to work with the technology and started developing some additional capabilities on the KnowThings algorithm, like clustering and entropy weighting, which let us actually now start to recreate the actual data, so and represent the physical system's behavior. So the real issue is if we want to move forward and take advantage of sort of what we can do at the compute level, these problems are there's not enough smart people on the planet to solve each and every one of these. We needed to use the smart people to build a tool, to build a AI. It's not, well, a machine learning that can actually help them with their jobs. So, now if I want to represent, what's going on in a greenhouse, instead of getting people who understand all the thermodynamics, build out a longer term model, we can capture some real data from a real system and how it interacts, and then generate that simulation in just a few minutes. So I don't really see it as an either or. We work in conjunction. It's just gone to a next level for how they have to be smart, not just in the specific problem, but it's like, how do I solve all forms of this problem?
Right. So our next question we have here, it has to do with, as we've had other AI self-learning companies here on the show, and one of the big problems is like you can train in artificial intelligence, you can train something on a certain set of data, but then when you need it to solve maybe a different kind of problem, even if it's related, you pretty much had to start over from scratch. You had to wipe the whole thing and give it new data, because then it would try to maybe solve it in the wrong way, or it would try to rely on things that just aren't really your best use case. Do you have any kind of effort with that? Or because maybe some of your customers, they want to test one thing and then just jump right into tweaking it just a bit?
So, I mean, I think you'd mentioned earlier, hadn't heard of people trying to use machine learning in here. So, I mean, some of the, and we really are machine learning. I need to avoid using the AI term. And I really wish I had my CTO, Menka Goyal, who helped pioneer this work with the University of Swinburne. She could tell you the details and get into it really at that mathematical level. But when you think about the traditional AI and a lot of what we're using, it's looking at predictive analysis, and the hard work happens completely in real time, and you have these large data sets. in the end, we're really doing sort of a language interpretation problem. So we're solving a different problem than a lot of AI or machine learning goes into. So we model a small individual device to start. So your typical IoT device, even more complex ones, are still only sending maybe 100 data points, and they're very simplistic type of data, right? This is temperature, or did the door open, or occasionally you have some audio or video streaming, but they tend to be these kind of simple data points that we're just trying to interpret and then create a new version of. So we don't need very large training sets. We can actually create a very rich model for some simple devices, with only a few hundred transactions or only a few hundred samples, not the millions or hundreds or thousands that are typically required. And part of it is because we're looking at a very, very specific problem, and we have developed a couple of very clever techniques that, they're not going to work for predictive analysis, but they do work for us to do the synthetic data generation and for us to understand how the computers are speaking. So there is that problem to a limited degree, but we have mitigated it quite significantly. Again, we're talking orders of magnitude less data needed to train a virtual device.
So, we're by the way, we're poking around on your website. Anyone out there who wants to go check it out, KnowThings.io. There's a link in the show notes. But you have, a couple of different buttons here. One for IoT makers. So, I can only imagine that, to make smart devices smarter, they would use, your kind of software and, kind of analyze the best way to utilize those sensors that they do have. And so there's that. But as I understand it, you just released a developer program, and I see here 4 developers. How do developers fit into, KnowThings?
So as we're getting started, and one part of it is I'm a developer at heart, right? I've been coding all of my life. I don't get to do it as much for work as I used to, but I really love doing development. And for the early stage, I think some of the biggest consumers for KnowThings are going to be developers, right? One of the challenges I've had many times myself personally is I don't have the device that I need when I'm trying to write the rest of the code and all the pieces that consume, so I can work on the hard problem, but I don't actually have a device in front of me. Or, as I have done on a couple of occasions, accidentally sent bad code and totally burned out the device, right? I mean, I spent too much of my life in enterprise as far as the career, so I forgot, hey, when I'm interacting with the physical world and I have bad software, it can have an impact on the real world, like start a fire. So there's a lot of value for developers to use the kind of virtual device, and we think that's going to be some of our, the early adopters are really going to be a lot of developers. But we're also, as part of our plan, want to take this and make it more available to architects or even people who are just trying to dabble, and that's where the machine learning helps. You don't have to be a programmer necessarily to use it. But as we're trying to test this out with as many problems as we can, we're reaching out to developers to come along, hopefully with us on the journey. We give them the early access to the machine learning for free, try to develop some interesting use cases. The IoT world is spreading in places I can't even imagine, and I'm sure just 6 months from now there'll be whole new sets of problems. So we've done extensive testing in the lab in terms of our ability to handle hundreds of thousands of transactions, lots of different problem spaces, but there is nothing like putting it in front of developers who are going to hack at it, break it apart, figure out where all the holes are, and even more importantly, they will probably have better ideas and really innovative ways that we can use this machine learning to really get total solutions built and out the door as quickly as possible.
So if I'm getting this right, and feel free to patch any holes here, but it seems like so you can essentially emulate or recreate a physical object, an IoT device, software-wise, so that you could run your software and you could see a virtualized version of your hardware, and then you could take that to improve your hardware. So you can work on your software before your hardware is done, and then you can develop your hardware so it better works with the software that you've created. Like, how valuable is that to a company that you can have all this done before you ever, contract with a company to manufacture devices that, hey, may have to be thrown away because they're not, good enough?
Well, so that's sort of the thing. So if you look, especially in the IoT space, and one thing I want to just make a small clarification,
Sure.
we don't emulate how the hardware itself behaves. We emulate how it communicates.
Okay.
So if you're actually, working on the chips, at the specific device level, and you're concerned with how the digital channels actually work at a controller level, we're one step removed from that. But now you need that to participate in an ecosystem, and that's where we do have a lot of value. And if you look at how an IoT solution is built, and I don't want to name any names, but companies aren't doing it themselves. They are usually bringing together a multidisciplinary group, of a lot of folks with system integrators and others to help put all this together. So what happens is you get a really brilliant embedded designer, and they start designing the device. Meanwhile, the other stakeholders get together and they talk about how, how do we actually now get this on your mobile phone? I mean, I'm going to use that as an example just because it's easy, although my personal view is devices should talk to devices. We shouldn't look at them on our phone.
Sure.
They should do everything magically in the background for us. But that being said, so the guy designs the device, but you still have all that cloud software and all those middle layers that you need to build and test. And so how do you do that today without something like KnowThings? Well, your embedded guy may write a whole technical specification document, and these can be 80 pages long telling you every bit and every byte it sends. And your average software person takes a look at that and goes, what? So, or your embedded guy learns some Python and he writes a simulation so that the upstream consumers can start to interact. And then what happens 3 months down the line? You know what? We need some slightly different data. As we thought this through, we make a change. So the embedded designer makes another change. Now he spends another 3 weeks giving you another simulation. So all the upstream consumers and everybody who's participating to build the solution knows what's going on. And so there's a lot of churn and a lot of wasted effort. With a KnowThing, since the embedded designer has built one version, when he does it, he creates that simulation in 5 minutes. And now you share that with all of the upstream consumers. And there's no mistakes that can happen here, right? I can't misread the tech document and make a mistake. I have a real life representation of it. Also, when those changes happen 3 months or 6 months down the line, hopefully just before you get to production on the electronics, when that change happens, another 5 minutes, you have a quick update. And now, again, you can start to react and move very, very quickly to these sort of changes. And you can be testing out the middle tiers and the cloud layer and how your customers will actually experience everything while you're still waiting for that lead time for, say, the radio to be built or that sort of manufacturing. So it may sound a little crazy that you can actually start doing that kind of simulation at the early stage. But when you get into how the sausage is made, we shorten the time taken and really reduce a lot of that resistance.
No, and that sounds kind of great. I mean, I'll be honest, radio show host and not actually, someone who develops IoT devices and things like that. Talk about someone who maybe is doing it without KnowThings, and then they want to switch over to using KnowThings. What's the learning curve on developers, or even IoT manufacturers adopting your platform? Is it something that's just going to fit right into what they know, or is this, do you have to essentially be trained on your platform?
Well, so we are about to do our first release, so I can't make promises. What I can say is the goal here is to actually make it available and usable even by non-developers, particularly people who just want to design. Even for myself, while I've done a lot of this kind of automation, when I was younger and played around with electronics, that's not what I did for 15 years. So, I mean, I can even talk about my own kind of learning curve from being a maker, which was early on just trying to automate my house. This was about 15 years back. And working sort of with the live, I have no idea how most of the devices that I bought at that time actually worked. And when I was testing everything out, I accidentally wake up my wife and my dog at 4 a.m. by triggering the panic function and causing all the lights to flash, the stereo to turn on. And I'm like, I cannot keep doing this. So I really wanted something that I could just plug in on the network the same way my software would talk to it and just behave like the device. So the ultimate goal and the way that we hope for people is that it will fit in with what they know. that if you're used to, as a maker, I would still consider myself a maker, at least on my nights and weekends. And you don't have a lot of time to go learn a whole lot of expensive or very detailed tooling or invest a lot, right? This is something that you're doing out of passion, out of hobby, in your free time. So you really want something that's as close to plug and play. Now, is it quite that? Maybe not, but I can guarantee you it's going to be a lot easier than actually connecting a real device to your computer or building out a lab, even at the small scale. It's going to be a far easier than your alternatives, even for, again, like people with Raspberry Pi and Arduinos, really exposing this to hobbyists. It's got to be easy enough for them to use. I don't want you to be trained on my tool.
Right. No, it's I'd say about 15 years ago is the at the house that that we recently purchased, it had automation from 15 years ago, and it was complicated. It was so complicated to the point where if you wanted to if you wanted to unsmartify the house, it would be just as expensive as just kind of keep doing what you're doing. It's very complicated, and I know firsthand that even in simple things like just upgrading software, that is a whole kind of thing onto itself. So I mean, hey, KnowThings sounds extremely valuable for for people who want to, like you said, just kind of do things without actually blowing up a light bulb or starting a fire in their house. So I mean, we have here as a startup accelerator, there's lots of advice that you can give to others looking to start up an accelerator business. So real quick, just some definitions. What is a startup accelerator? And hey, what are some lessons learned from founding a company? Because hey, that's pretty hard work in itself. So
I think a startup accelerator, and so the one that I participate in is from CA Technologies. I've worked with them and for them for quite a long time. So it's an interesting trend that you see, I think, with a lot of larger established companies, right? Historically, you buy a startup and try to take it, as it's growing, and you hope you hit the right exact spot on the revenue curve, so that your investment in buying a startup, makes actually generates good returns.
Mm-hmm.
But that's like sort of an older and dying model. So I mean, CA is not alone, but we've decided instead let's just start directly funding those startups. Let's do that innovation in-house. Let's get it started and really almost behave like a VC or set of angel investors for the next generation of innovation. So that's where KnowThings came in. CA Technologies provides the funding, allows us to exist, and lets me take advantage of some of those research partnerships that I developed over the years. But at the same time, there are no handcuffs. I'm out here really just trying to build a business and on my own with the team that I have, but I do have that good solid financial backing. So I think so the accelerator is sort of this idea of how do we actually grow innovation at the early stages rather than waiting to try to strike at the right time on timing of markets. So
right.
That being said, I think with the best advice I can give, if you're trying to do your own startup or come up with an idea, is forget about your solution. Your solution does not matter yet. The first thing you need to do is understand the pain and the problem for your customers. So, even though I didn't even follow my own advice because I had this cool machine learning, we had used it in the wrong space. And that almost talks to when we first started, we took a really cool idea, put it in the wrong place, and it didn't do very well. As we come back, look at your problem, understand what your customers really want, what they really need, and then develop your solution. But if you're not solving the pain of your customers and you don't understand how they talk about it, it doesn't matter how cool what you build is. Nobody's going to come. Many a startup has seen that.
Yeah, and one question I always ask, and I regret that I didn't ask you. And by the way, AK, we're actually about to run into a break. So would you mind staying over for just a couple minutes, and we'll wrap this up on the other side?
Absolutely, no worries. Thanks,
perfect.
man.
So, but yeah, but actually, before we go to break, though, I just wanted to ask you one quick question, and I might have to interrupt you, but I always ask, whenever someone tries to come up with something innovative or new or different, I always ask the question, what's changed? What's changed in the last couple of years that allows you to do this? Is this strictly a computing power kind of thing that lets you do this? Or is it that you are the only one in 7.6 billion people to think of this? I mean, I'll ask you, okay, what's changed that let you kind of start KnowThings? Actually, I'll take it back. Music's just started. We're going to stop right there.
Right.
And then we'll come back and we'll ask that question again and we'll get into it. So everyone, one more time, knowthings.io if you want to check out their website. And again, a link to that in the show notes at computeramerica.com. So music means we're going to take a break. We'll be right back with more of this interview. And hey, later, computer and technology news. Everyone, stay tuned.
Dish TV is better than cable TV. Why? Because you can save 45% on packages compared to your high-priced cable bill. Wow. Take those giant scissors out and cut the cable and save with Dish TV. Plus, you get a free DVR upgrade to record your favorite shows and free installation. And with Dish Anywhere, you can watch TV for free on your mobile device. Act fast. You can save hundreds of dollars. Does your cable company do that for you? I don't think so. Get all the best TV programming at your fingertips at a fraction of the price of cable TV. So say adios, arrivederci, goodbye to the high cable bill and save up to 45% on Dish TV packages today. These are limited time offers and can change at any time. Call fast.
800-471-5325. 800-471-5325. 800-471-5325. That's 800-471-5325.
Greece is cheap.
But the airfare costs a fortune.
Paris?
Not much closer, and again, airfare...
What about Puerto Vallarta?
Let's face it, flying anywhere is just too expensive.
Wait, what's this? Low-cost airlines.
With one call to low-cost airlines, you'll drastically slash your travel costs. We're talking insanely low airline prices to any of your favorite destinations. Where would you like to go? London, Rome, Costa Rica, Australia?
Wow, that's cheap.
So why wait? Call now to learn how crazy cheap it is to fly anywhere in the U.S. or international. Our prices are so low, we can't publish them. The only way to get them is to call to instantly hear the most amazing best deals on airline travel. It's that easy. So call now and start packing.
800-215-4461. 800-215-4461. 800-215-4461. That's 800-215-4461.
And welcome back to the Computer America Show. It is 32 minutes past the hour as we continue on here with KnowThings, and we are talking to the CEO and founder, Mr. AK. And so, yeah, I can apologize, but just for the break, if you're just joining us, we are just asked a question concerning, kind of what's changed, because there's no doubt that the Internet of Things, I would say, if you had heard the phrase Internet of Things in 2013, 2014, unless you were a select few, you probably didn't know the term. Nowadays, I think it's pretty common nomenclature. So I guess my question to you is, what's changed over the past couple of years that allowed you to start KnowThings?
I mean, I think largely the changes are external, right? We had the cloud that was coming in earlier. We've had advances in edge computing, right? So the smartphones, all the things that are making computers smaller and tinier, finally created sort of the background and the gestalt that was needed for these type of solutions to exist. Nobody could do it alone. I mean, you needed tiny computing. You needed also giant computing and ways of sharing that with networks and others. So I think we largely reached, as a society, as a digital society, we reached that critical mass necessary for some of these transformations to start. As to how we got to know things, honestly, we do it. Things changed because we failed the first time. So, I mean, I still remember the conversation. Me and Steve Versteeg, who coordinates the research over at the University of Swinburne, and my CTO, or my current now CTO, me, Stephen Manko, we're talking, throughout late night, trying to figure out why did this machine learning thing not do what we needed it to do and work well in the market. Really looking at something that was so cool but didn't succeed. so it wasn't even a unique idea just to me. It took the three of us in a room going, there is something here. There's something useful. Some of my background and my interest in that automation, and it's a big passion. I was, was like, well, what if we look at this from this type of perspective? And Steve, I think, hopped on it right away. And he's like, hey, and guess what? Not only can we do what we do today, but we can start to make these devices interact and start to do things that look like the real world, right? It was just that right conversation at the right time. And also based upon just trying hard, trying to be clever. And when you don't do well, you don't pack up and leave. You take a look at it. You see what worked, what didn't. I've been very blessed to continue to be able to work with Steve, Menka, and have built a really good team at KnowThings of really smart people. And yeah, I mean, one, society was ready for it. You've got me. A lot of people, I guess there's a time for things, right? How did cloud develop? I was also involved with a lot of the networking in the early days of that. And it was sort of, to your point, 3 years ago, nobody knew what IoT was. And when cloud came out 3 years before anybody knew the term, it was virtualization and nobody had an idea. But, once that technology is out there, once humans know what is possible, it is frankly amazing how fast we develop that and change our societies and ourselves to take advantage of the new things that we learn. The digital revolution allows us to share those ideas better and faster. And frankly, I don't know how to build the products that make the world better. What I do know how to do, I have a lot of experience, is helping people build things. And so I got together a lot of other people who have that same passion. How do we build good tools? How do we enable the true geniuses of the world? And that's what we're trying to do.
And that, of course, flows pretty nicely into the last question I think we're going to ask you, which is, where's this all going? What is the future of simulation, of IoT simulation? What is the future of KnowThings? 3 years we see such radical shifts. What do you see in 5 years?
So in 3 years, let me take both of those points, right? I suspect in 3 years we'll start to see simulation, and hopefully it's primarily from KnowThings. But it won't be anything. It won't be as big a deal to talk about, right? It'll be commodity. You will order up devices on your phone, or the same way that you interact, say, with Amazon or Azure or AWS or any of these kind of systems. That it's just part and parcel of how you work. If you went 20 years back, having an integrated development environment for doing your coding was new. Now that's just there, right? You can get them right on a web page. Mm-hmm. But if I want to go further, and if I really think 5 or maybe 7 years down the line, frankly, I want us to become invisible. It should be something that is, because I think there's a tremendous potential to accelerate how you build things. It'll won't mean anything more than a wrench to a mechanic, and it will be something most people don't care about. They're not aware of, because it's just been woven into the fabric of how we build the next generation of solutions. I did say I don't always know exactly how developers want to use it, but I do think there's a best practice and a method of engineering that simulation really drives. You can't really automate at this kind of scale if you can't simulate. And so, I think the future is nobody's talking about us anymore because it's just part of the ecosystem.
But your tools are making it making development faster, cheaper, and just gets those other tools kind of out there even quicker. So hey, it's technology is very much a snowball effect. When if something like yours is readily available to everyone and it's just the cheapest, fastest, best way possible, then hey, that benefits a whole lot more people than than just yourself. So hey, I think that's awesome. And why don't we go ahead and wrap this up by saying, if people want to find out more, and what can they find at your website?
So right now, the big thing on the website is I want developers. I am one, and we want some more of them. So we have our early adopter program, and so you can go there, you sign up. And at that point, you have direct access for KnowThings. First release should be coming up the end of next week. You have direct access to our engineers and the smart folks who built it, and we want to get your feedback and really build the best solution out there. And if you're doing something cool, we want to promote it, right? So we're looking for developers building cool things, test out our simulation, kick the tires. and we'll give you the tool for free, as well as if you're building something cool, we want to tell the world about the cool solutions that you're building and how you built it.
That is just awesome. So, and if you're watching the video portion, we're showing you that right now, or you can head on over to knowthings.io. And yeah, AK, I want to say thank you so much for coming on the show. This was, it was a little bit over my head, I won't lie, but I think if you're a developer, you understood most of this. And hey, this is again a couple of things you said I've never heard before, and that's pretty hard to do. So hey, thanks for coming on the show and explaining this to us.
Hey, thank you so much for having me.
All right, have a great one, and yeah, good luck out there. Thanks.
Thank you.
All right, everyone. So there he goes, and all right, so yep. And again, KnowThings. And if you missed any part of the interview, by the way, if you're just joining us, be sure to check out the podcast version of the show, which is just the entirety of today's program, rebroadcast wherever podcasts are heard. So, places such as iTunes, Google Play, things like that. Let's see. Some of my favorites include SoundCloud, Google Play, iTunes, iHeartRadio, TuneIn, of course, Blog Talk Radio, and of course, hey, if you weren't able to listen to us live here on IRN, well, there you go. So everyone, I think next we're going to go ahead and do computer and technology news, and this is brought to you by OWC. So here we go. All right, let's get started by, we have a number of articles, but I wanted to do a couple of these that we actually collected yesterday. Yesterday, unfortunately, we did not have a program, but, the stories are still relevant. I think even just being 20 hours old, it's going to be okay. So why don't we go ahead and talk about this one? So, gold. It's valuable. There's no doubt about it. If someone offers you a bar of gold, you say, heck yes, I will take that. Well, what about nanoparticles? What about nanoparticles of gold? Not quite as valuable, unless apparently you are looking to store data for a long, long time. So this from Business Insider Australia. And they say that science says, because science says a lot, but science says nanoparticles of gold may be the answer to storing data for hundreds of years. That's pretty darn cool. So this by Chris Pash, and they said that researchers from Australia and China use gold nanoparticles to create a new type of high-capacity optical storage disk, which can hold data securely for more than 600 years. And yeah, when you look at storing data, the failure rate of a lot of our current methods in 600 years would almost guaranteed be 100%, 600 years into the future. So the technology promises a better solution to the global data storage problem, where the explosion of data in cloud storage has led to power-hungry data centers. And of course, there's more to this. Let's see if they overcome some of the other obstacles in storing data. But let's see. So they say that the centers, which are data centers, currently consume about 3% of the world's electricity supply and rely on hard disk drives with limited capacity, up to 2 terabytes per disk, and lifespans of only 2 years. Although, of course, those are increasing all the time. But check it out. Now, scientists from Melbourne's RMIT University, they said that they have used gold nanoparticles to demonstrate a next-generation optical disk with up to 10 terabytes and a 6th-century lifespan. There's a couple of reasons I don't like this already, but let's go ahead and continue with the article. Of course, they say that all the data that we're generating in the big data era, which is over 2.5 quintillion bytes a day, has to be stored somewhere, but our current storage technologies were developed in different times. So, while optical technology can expand capacity, the most advanced optical discs developed so far only have a 50-year lifespan. All right. So some things that immediately jump to mind with a problem with this is that even when you look at, I'm sure a lot of you have seen it. They're promising 600-year lifespans. The immediate problem with that is that when you look at, let's even say 50 years in the past, when you see like these MIT, IBM storage solutions where it's like, hey, this is like 600 megabytes, and they're loading it onto a train with like a forklift. It's massive, 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 massive compared to what we have nowadays. And even if you had like 1 gig of memory back then, 1 gig of, 1 gig of storage, that really doesn't mean that much nowadays. Because if you had a 1 gig drive, that's like nothing. That's a USB thumbstick. My problem with a 10 terabyte, which is admittedly pretty big, in last 600 years, is that that's even looking 60 years in the past. What if you look 10 times that into the future, where, as I said with our previous guest, a lot of technology has a snowball effect. It doesn't really slow down. I'm not saying that it has to stick to that doubling every 18 months kind of curve, but it's going to stick pretty darn close to that. So with current technology, that may seem pretty cool, and the long-termness of it all is pretty great. But what happens in another 50 years when 10 terabytes looks like, child's play? When it's like, oh yeah, I have that, stored in my DNA every single day. It doesn't matter. These things are nanoscopic. And that's, 60 years into the future. What's 10 times that look like? I don't think that there is that much of a demand. There's probably not that much of a demand for 600-year storage. What there is a demand for is, very constant, dependable, not going to be defective storage. So, maybe store something for 20 years and you can guarantee that in 20 years it's going to be perfect. That has a lot of value. But even after so much time, storing 10 terabytes is going to look just plain silly. Because, hey, with the increase in technology, it's not just that file sizes have gotten bigger, but bigger file sizes have allowed us to do even more things. It's not just, some kind of problem with compression. We prefer things to be completely uncompressed, as best that we can, even in sending. So I just don't see that much of a use for something that only has 10 terabytes in the next 50 years, let alone in the next 500 years or more. But anyways, they say that, to continue on with the article, the novel technique behind the technology, developed over 5 years, combines gold nanomaterials with a hybrid glass material that has outstanding mechanical strength. And they said that glass can last up to 1,000 years, but has limited storage capacity because of its inflexibility. The team combined glass with an organic material, halving its lifespan but radically increasing capacity. So, gold nanorods were then incorporated into the hybrid glass composite, and the gold nanoparticles allow information to be recorded in 5 dimensions, where you have 3 dimensions in space, plus the color, plus the polarization, because it's a metal, so color and metal. So, let's see. They say that the paper, high-capacity optical long data storage memory based on enhanced Young's modulus nanoplasmonic hybrid glass composites, is published in the Journal of Nature, Nature Communications. So if you want to read more about it, but yeah, there are obvious problems with it. I don't think anything needs to last 600 years. I think data probably should last 600 years, but the form factor, the storage that we actually use, that's guaranteed to be obsolete within 600 years. Maybe failure rates. Maybe that's something that they can really improve on. But at current, it's kind of whatever. All right. So there's that story. Again, I kind of liked it just because it was about gold. Let's talk about something a little bit more down to earth, actually happening, and hey, pretty uplifting. Where North Dakota, no offense, North Dakota, I really don't hear that much about you. I'm sure you're doing things, and I'm sure they're great things, but at the same time, North Dakota news is pretty rare, especially on a technology show. But check it out. This coming to us from Telecompetitor, and they say that Gigabit coming to every school in North Dakota thanks to a new 100 gigabit per second backbone network. Pretty darn cool. So, and they say that North Dakota is somewhat of an anomaly in today's broadband world where so many lack access to high quality broadband. And the largely rural state has some of the best, if not the best, statewide fiber connectivity in the country. And it's about to get better. Where the Dakota Carrier Network, a regional fiber network operator owned by several independent telcos, has committed to enable 100 gig backbone for the network that serves schools, colleges, and government agencies by 2019. And yeah, they say that it's an upgrade to their current infrastructure and will ensure universal gigabit broadband capability, again, for schools and government buildings. That's pretty awesome, especially for somewhere as diverse and, well, they said it rural and spread out as North Dakota. That's pretty darn awesome. So they said that it's an honor for DCN and our 15 owner companies to provide gigabit internet service to every K-12 school in our state. DCN has been keeping North Dakota public school connected since 2000, and we know that reliable, fast broadband connectivity is key to keeping our children competitive in an increasingly digital world. Pretty darn cool. So, let's see. According to DCN, the 15 telco owners have invested over $1.2 billion in their collective networks, where we're investing over $100 million per year in fiber network construction over the past 5 years, and DCN owner companies serve more than 164,000 customers in 250 communities. So, again, they don't have the user base that a lot of other telcos have to offer, but at the same time, they're doing things that it seems like they're doing it better. They're doing it better than some of the more recognizable telcos that that we hear about all the time. All right, so why don't we go ahead and talk about? I guess there's no avoiding it. We have a couple minutes here. We might as well talk about it. And Facebook, they've been having a rough go of it for the past couple of days. It's no secret that ever since the whole Cambridge Analytica and the selling of data, it's really raised a lot of questions about, why are we trusting Facebook with so much data and just how much influence that company actually has. Well, there's a new article out today by Maya Kosoff saying that Zuckerberg hits users with the hard truth. You agree to this. And yeah, and Facebook tells horrified users it's explained right there in the app. So after embarking on exactly the kind of cringe-inducing apology tour one would expect following the revelation that Cambridge Analytica plundered the data of millions of Facebook users, Mark Zuckerberg has yet another mess on his hands, where over the weekend, Android owners were displeased to discover that Facebook had been scraping their text and phone call metadata, in some cases for years, an operation hidden in the fine print of the user agreement clause until Ars Technica reported it. Well, Facebook was quick to defend their practice as entirely above board, and they said that small comfort to those who are beginning to realize that because Facebook is a free service, they and their data are by necessity the products. Which, again, we kind of already knew. If you are using Facebook and you never paid a dime because there was really no way to pay a dime, then anything and every way that you interact with Facebook is being used for monetary gain. So I mean, great that people are finding out about it now. It's just a couple of years late. But anyways, this is mainly talking about the Facebook's Messenger app. And the Messenger app did a lot of things in the past that it doesn't do nowadays, but it still does a lot. Where they said that the Facebook Messenger application requests those who download it to give permission to access incoming and outgoing call and text logs. But as users discovered when prompted to download a copy of their personal data, a certain amount of data was covertly siphoned without explicit permission. And this is coming from a gentleman named Dylan McKay. He downloaded his Facebook, and yeah, he showed people, I think it was something like 6 years of his phone call. It was a lot of metadata. Anywho, Facebook responded with a blog post laying out the applicable user agreement terms and denying that Facebook collects call or SMS data surreptitiously. Because they don't do it surreptitiously. They do it right in front of your face. They even say, again, in the fine print, which no one ever reads, they're going to do this. So, but the revelation couldn't have come at a worse time for Facebook, which is trying to dig itself out of the Cambridge Analytica fiasco. So on Sunday, the company released a full-page print advertisement saying that, in an attempt to regain public trust in the ad, Zuckerberg called the Cambridge Analytica leak a breach of trust and apologized, reassuring readers that we are now taking steps to ensure that this doesn't happen again. But so far, it seems that they have missed the mark, where according to the poll done by Axios, they said that the favorability rating has dropped twice as much as that of other tech giants in the past 6 months. So, and I don't know, I guess we here on Computer America, we've had a bone to pick with not just Facebook. Don't get me wrong. It's not just about Facebook. It's also about Amazon. It's also about Microsoft. It's about a number of different companies that unilaterally have too much control over too much data. And the rights of your data come second to the rights of their profit. That's the way that the internet has been operating. I can't say that that's exactly the wrong way. It's just the way that we've allowed it to grow. And obviously, whoever can earn the most money is going to be the most successful. There's just no two ways about it. But it's a question of when is too much too much? When we give over too much of our lives, there has to be a line drawn. And Facebook is going to get hit with it here real soon. I just don't think that Facebook is going to be the only one to be hit with it here real soon. So, hey, it's going to be an exciting time over the next couple of months and, hey, even the next couple of years. All right, so don't have really too many other articles that we're going to cover today, just flat out of time. Let's do this last one just real quick, just broad strokes. Netflix, you may have heard of them. They supply you B-rate movies directly to your home, and sometimes there are some gems in there. But Cannes thinks that, well, they're going about it the wrong way. So this is from The Verge, and Netflix banned from competing at Cannes Film Festival. You may have heard about this one. Cannes is a pretty prestigious, one of the most prestigious places to be awarded, awards. And the problem here is that Cannes has, because it's held in France, they've had a rule that any movie that wants to compete in Cannes has to have a theatrical release in France. And it has to be in so many theaters for so many days. And even if a movie knows it won't sell any tickets in France, they still have to meet that quota, and they still, they meet that quota, and they still feel like they have to, and they still feel like they have to do that part of the whole rigmarole. There we go. Well, Netflix doesn't follow that, because if they did, then they couldn't release their own movies on their own platform for 3 years thanks to French law. So they decided to not do that side of it and instead go their own way, try their best, and hey, this is what you come up with. So, hey, it may not be the best solution, but cans is no longer welcome in Netflix. So, with that being said, folks, we're just about out of time. Thank you so much for joining us here on Computer America. The music means that we are just about done. If you want to listen to this show in its entirety, feel free to check us out wherever podcasts are heard. And hey, be sure to check out KnowThings.io, who was our guest today. So, with all that being said, hey, until next time, thank you for joining us here on Computer America, and be sure to tune in tomorrow as we have on the program, get this right, Scott Schober. He is our resident cybersecurity expert. Always a fun time. And folks, until next time, have a great one. Bye-bye. Thank you so much.